morning, everyone. Thanks for making it up. I barely did. Um, Welcome to A Brief History of CTF Talk. I do have a challenge in the I can't have a CTF talk without a CTF challenge, but it might be broken. So I just want to preface this with, I couldn't get my payload working, but it was like 5 a.m. when I finally got it set up. So my excuse is that I was tired. But you guys hopefully can solve this if you want to get your phones out and take a picture of that one. The password to the account is just Insomnihack. I think I got the permissions set up where you probably can't screw with each other, but there's probably still a way. So be nice and see if you can solve the challenge. There's a /flag file that's only root readable in a SUID binary with source. I mean, come on, I'm really making it easy on you because I know you only have a few minutes. So if you can solve that challenge during the talk, that way at least if I'm boring, you have something else to do. So this is my unbio. It's not my UN bio. I know we are in Geneva, but this is the things that I am not. So I want to be very clear. I am not the best CTF player by a large margin. I'd say Loki and GeoHot have pretty good claims on that. I'm not the winningest DEF CON CTF player. PPP has beaten me more times. I'm not even the organizer of the longest running CTF. Shellfish has done that, the same kind of organizers. And I'm not the longest continuous CTF player. Chris Siegel has been playing for way longer than that. I'm not even a current CTF player because I've retired. I'm too old and slow, and my hobbies are different, and this is very sad. I wistfully look at CTFs these days, but I haven't played in at least a year and a half now, and this is very sad. But what I am, though, is somebody who has played a lot of DEF CON in the past. I've played a lot of CTF, won a couple times. I helped build Cyber Grand Challenge, which is a really fun, massive CTF, probably the biggest in terms of infrastructure and overall investment of time and money CTF that's ever happened that was put on by DARPA. I was captain of the team behind Ghost in the Shellcode, which has some memorable challenges. I run captf.com, which is a collection of CTF challenges. And one time I ran a CTF award ceremony just for 1 year, but hopefully we can kickstart that again later. And I'm one of the developers of Binary Ninja as well. So quick survey. Who here has heard of Capture the Flag? I mean, you're in the talk, so right, yeah, you have to do that. Okay, who has played a Capture the Flag? Keep your hands up. Excellent. Now, who has knows their current team CTF time rank? Who could tell me? Yeah, okay, a couple of you are like, yeah, we know plus or minus where we're at. Who has organized a CTF? Has run their own CTF? Excellent. That's a good chunk there. And who has retired from CTF like me? Any retirees? Yes, good. Retirees, we can join together afterwards. Maybe tonight at the CTF we can form a new one. Okay, so I'm going to skip this because you don't need to know what types of CTF are. In the beginning, at least for me, it wasn't quite my very first CTF, but one of my first CTFs was the DEF CON CTF where we submitted via DTMF. I don't know if anybody were here. I know that I think I was talking to one of the pandas who was there for that year. You actually were given a telephone cable to submit your keys. So you actually had to dial 10 DTMF into this asterisk VoIP server. So that's the beginning of sort of my CTF experience. I'm going to reference DEF CON CTF a lot because I've got the most experience probably with that. But clearly there are a lot of other worldwide CTFs. My stories, my experiences are certainly biased towards what I know. And so I would love to have you guys tell me more about what I don't know of other CTFs and different areas. But I don't expect you to read this. This is not meant to be readable for reference. This is a Google Sheets document that is open, and I would love to have contributions and comments and fixes if there's things I'm missing. But this is kind of a detailed look at the history in terms of what architectures were used, what are the kind of notable key events. I want to cover two of them now. And one is Badger. Badger was really, really cool. This was one of the legit BS DEF CON CTF games where they built a custom Wi-Fi badge. Except it wasn't actually Wi-Fi. They built their own custom RF protocol, and it was spread spectrum frequency hopping written by hand. They wrote everything by hand. Also, it was running two MSP430 cores virtualized on top of a Xilinx FPGA. They had to have two cores so they could have their out-of-band command and control and like the flash and the emulation for their game infrastructure, as well as the one that you could reflash. This is a really, really impressive piece of design. And this predated the sort of current trend of badge explosion. If you were at DEF CON this year, there was like 50 badges and some really, really cool stuff that people are designing. But this was a completely ground up, hand done piece of love. It was really, really impressive. Unfortunately, there was a minor bug in it, an off by one, so that Team Zero couldn't score, and Team Zero happened to be PPP that year, and they happened to have an exploit before anyone, and struggled to land it, never got it working during the game. But thankfully, Routards, is any of the Routards players here, the French CTF team? No one will admit to it if they are. They were one of my favorite teams to compete with at DEF CON because they always got second. I always felt so bad for them. They were second more than anyone else in the history of DEF CON CTF, I believe. But they were great sports. They were the only team to successfully land an exploit on this badge during the game. They have a very nice write-up in the slide notes. You can read kind of more the details of what the exploit was. I had actually worked on one of the exploits for our team. I think they may have even helped Routards land theirs because ours, we were throwing it and it was failing, and they pulled ours off the wire, and I think it might have helped them. But Clemency is an awful piece of work. If you played DEF CON this last year, it was a terrible, terrible thing that was done to you. I'm sorry for that, but I think many of you may have enjoyed that pain. Clemency was a custom architecture. You might have heard about this, where it was middle endian. It wasn't big endian. It wasn't little endian. It was middle endian. And this is just because lightning is evil. There is no other explanation. It was, also 9 bits, because why would you want a power of 2 for your number of bits, which made your translations from network to in-memory byte encoding super awful. It was really, really terrible. And the worst part about Clemency was they gave everyone the design doc for it the day before the event. And I had actually been arguing. I'm good friends with the LegitBS organizers, and I had known about it for a while. They had talked to us and said, hey, would you make a Binary Ninja plugin for this? And we looked at it and said, no, that's way too much work. There's no way we're going to make a plugin to support this awful architecture. Although several people did hack together some plugins during the event. But I was really impressed. A lot of the teams at the finals were able to adapt and take this crazy architecture, weirder than many other architectures you've ever seen, build working tooling in less than 24 hours, and then play a CTF and write exploits on that architecture. So that was a really, really neat challenge. Now, in terms of the overall total CTFs, thanks to CTF Time for their kind of archival data, you can go back and look and see where we're at in terms of total CTFs. Just in 2017, we had about 140. So we're not quite at every other day, but we're closing in there, right? Where you could literally play a CTF every other day. And if we assume that CTFs run for, 2 days a piece oftentimes, then we're looking at every day of the year, you could essentially be playing a CTF if you spread them out. So there are an insane number of these capture flag competitions that are going on. And that means there's something for everyone, right? There's different styles, there's different challenges. I'm going to not spend a lot of time on scoring mechanisms. Suffice to say that that they exist, and for attack defense competitions in particular, they're very fraught with risks. Right? To try to make sure that your teams are playing legit, or at least the way you want them to play, you're getting the right behavior out, requires a lot of incentivization. So you really have to think about, when you're organizing a CTF, how do you score? Do you let teams? How do you prevent teams from replaying services, from replaying attacks? Do you want them to for some services, but not all? You need to have some sort of polling mechanism. You want to make sure that they don't just turn their services off, because it turns out an unplugged server is a very secure server. It's just not a very useful one. And so you have to sort of incentivize the proper behavior. Jeopardy style, of course, CTFs, the sort of more scoreboard based, they tend to have sort of different scoring mechanisms. I really like the self-adjusting scores, where the scoreboard automatically balances itself based on the number of solves. It's really hard. Anyone who has ever run a CTF can tell you it's really hard to properly score a challenge, to come up with, this is clearly 100 points, 50 points, 500 points, whatever your scale is. You will get it wrong because someone else will think of something easier than you thought of that you didn't find. Or what you think is an easy answer because you know it and you made it is actually much harder to other people without that tainted knowledge. So one recommendation is that when you're building a CTF, have your teammates test your challenges. Teammates with no foreknowledge of what the challenge is to make sure you've gauged it appropriately. Now, there are a lot of fun Superman defenses, as I'd call them, especially in attack defense CTFs, where you're engaged heavily with other people. Some of them are really stupid, and some of them are really interesting. Service redirection is really stupid. For example, if you want to make sure that my service is running, I can just netcat to someone else's service and say, look, my service is still running. Ta-da. I'm still providing services. It interacts, is very functional, but you're not stealing my flags. That is not an interesting defense. It's not a technically a legitimate one. And so as an organizer, your job is to sort of prevent this and minimize this. But there are some other ones that are more interesting and you may or may not want to allow depending on the type of event you're in. Syscall filtering, virtualized services. People have wrapped services in QEMU. They'll actually instrument it so that all everything is passed on through it except for the open syscall, right? And they'll go ahead and trap that. And is it opening the flag? Then disallow it, right? And so you'll see a lot of generic defenses like that mean the team doesn't have to actually figure out where the vulnerability is, but they can just generically patch them all over the place. I talk very fast, and I know this, so I actually have slide notes to make myself slow down and stop. So I'm going to take a breath for a second, and I'm going to show you, if you're working on the CTF, what prize you're working for. Ooh. It's too early for audience participation. Okay. It's a mug. It's a insulated cup. It's got the Binary Ninja logo on it and some stickers. And if anyone else wants stickers afterwards, I have a whole bunch of stickers up here as well. There's a lot of fun network shenanigans too. All right. Real world impact. One of my favorite things about CTFs is that a lot of people look at these crazy challenges and they say, like, that's not very realistic, right? That's the most outlandish, ridiculous thing. That doesn't relate to real world exploitability. The weirder the challenge is that I've ever made, the more likely it is to represent something I worked on my day job as a vulnerability researcher. You would be very surprised at how often real world problems inspire CTF challenges and vice versa, back and forth. They're very, very often related. And so the skills you develop playing a CTF can be very, very helpful when you're actually doing reverse engineering and vulnerability research. I have a whole list of things, of challenges that have developed real world exploits and vice versa, and I don't even have time for them. So I'm going to skip them and tell you to go watch my Infiltrate talk that I gave a few years ago where I listed a bunch of them, and the slides are online so you don't actually have to listen to me jabber. And you can see there's been a large number of these challenges that were really had an actual impact. So this is not just a game that we're playing, but actually has inspired a lot of real tools and real exploits. One of the aspects of CTFs that is very near and dear to my heart is gamification. In fact, I actually quit my job at my last company 3 years ago and founded Vector 35, where we make Binary Ninja, so that we could actually build hackable video games. Our long-term goal is to build like a real MMO with hacking as a real game mechanic, not like, click hacking, but actually real reverse engineering, real programming, actual virtual architecture, those magic spells are actually code running in a virtual machine inside the world. And so the players will, like CTF players, you will all be wizards in this world. It's going to be an amazing place once we end up building it. But we thought we should make money first, so that's why we made a real product and tried to sell that. So, eventually we'll get there, we hope. If we do well, we'll be able to build this. But I think that there's tremendous potential. I think a lot of us got our start in security hacking video games, cracking software, doing these kind of like, I saw some nods, yes, it's okay. I like cracking software. I buy it and then I crack it usually. This is how a lot of us got our start. It's this challenge and this fun, this drive to solve things. And so doing that inside of a game environment where there's other people we're competing against, where there's sort of fun, interactive visuals, makes it a lot more interesting. One of the earlier examples of this was Choose Your Own Adventure. My team loves puns, and so Choose Your Own Adventure games were inspired by Zork and the text adventures of yore. Choose Your Own Adventure was, sorry for the pop on the P. Choose Your Own Adventure was a very simple game. Again, it was just a text-based game. You could follow through a little series of challenges where you had to get past rooms. And once you made it to the end, you had a different exploit, and depending on the route you had taken, there were different characteristics in the exploit that made it easier or harder. It was a lot of fun. But actually, a few years later, PPP in their Plaid CTF released a really cool game-like interface. Their scoreboard was actually like this world you walked around in the web browser, and two of their main exploiters actually spent more time building this web interface than they did challenges that year, because it was really cool looking, it was fun, but there wasn't actually any challenges like in the interface, right? The web interface was really just there to look cool and to walk around and interact with people. And so the following year after that, at Ghost in the Shell Code, we released Pwn Adventure 2. And Pwn Adventure 2 was complete overkill. It was a Unity-based MMO we had, I think, 200 something users, 100 something users simultaneous at one point, running around, shooting each other, hacking the game client, because you were supposed to hack it. To solve challenges, you had to cheat. And this was literally the point of it. Rusty Wagner, the co-founder of my company, was the primary architect of this whole series of Pwn Adventure challenges. He spent about 6 months, a ton of time, just building the CTF, building these challenges into it. And it was, because it was in Unity, it was .NET reverse engineering, which made it a great introductory challenge for reverse engineering. You didn't have to know any native assembly, but the .NET decompilers are pretty good. So the next year, we came up with Pwn Adventure 3. And Pwn Adventure 3 was based on the Unreal Engine. And so it was C++, much harder to reverse engineer. In fact, we actually use it in a training course that we just did a few days ago. I see a few students in the audience where we teach reverse engineering inside of this game, because it's a lot of fun to, like, you know, when you get stressed with the reverse engineering you're doing, to go shoot some stuff for a little while. And so the source to this game, though, you don't have to take the course. We've actually published the binaries for both Pwn Adventure 2 and Pwn Adventure 3 online. And so if you grab the slide URL at the end, you can get the links to that. But there was all sorts of teleport hacks, of flying hacks. There was some game glitches in the game. But most of the exploits in Pwn Adventure 2 and Pwn Adventure 3 were exploits of the client. You patched your client, you exploit the server, you were hacking the game infrastructure itself, one way or the other, right? The server trusted client input and would let it automatically tell it where its position was, when it should have verified that it was physically possible to move that fast between 2 points, for example. And so we kind of wanted to change this. And again, our long-term vision for a hackable video game is one in which the hacking occurs inside of the game, because when you break the game client too much, it sort of becomes not fun at a certain point, right? Because it's totally unconstrained. And so we wanted to build a world where we were using the game client more directly, and not just like patching your game client and cheating. And so Pwn Adventure Z, is a little dark in the background, was a zombie survival game. STRT actually has a couple copies, and so if you go out and see the TV, you may have wandered past it. It was written for NTSC and the NES's PAL, so the audio is a little distorted and it's a little bit slower, but it still plays fine. So you can go check out. You can try this game. Pwn Adventure Z is modeled very much like a Zelda. You'll see people are like, "Did you copy Zelda's sprites?" No, all of our sprites were hand drawn. We didn't. In fact, our trees have shadows, much finer detail than Zelda 1 ever had. So we're very proud of our little game. It's hand-coded 6502. But my favorite part about this is that Pwn Adventure Z takes its inspiration from the speedrunning community and the game Tazzing community. If you haven't seen the work being done by speedrunners, it's mind-blowing. All right, so people who just started playing these video games to go faster and faster and to try to like optimize their routes started doing what were called TAZs, tool-assisted speedruns, where they would frame by frame do perfect input into the game. And so they could come up with the most optimal solution to beating Mario or whatever the game that they're running was. And somewhere along the line, they decided, well, hey, that's weird. If we do this specific sequence of things, the game crashes. I wonder why that is. Well, the answer is they're exploiting it. They're exploiting it with up, down, left, right, and just using the controller inputs, they were able to create exploits to these games. They called them total control speedruns. They were exploiting the game. They were coming up with advanced exploitation technologies. Some of them didn't even know like security and software exploitation was a thing. They were just like, how do I make my game faster? And they came up with these fantastic exploits. Pokemon Yellow on the Game Boy has classically been done a lot. Super Mario World has been owned so thoroughly that they can jump to the credits by hand now, doing raw code execution in 41 seconds, I think is the current record. They just do some bizarre series of manipulations, many of which are pixel perfect and frame perfect. Frame perfect meaning once every 60 ticks, so 1/60th of a second or 1/50th of a second, they have to get an exact perfect timing on their button presses for some of their moves. So the fact that humans can do this on an NES controller and it can be pixel perfect on the screen is mind-blowing, right? This is really, really cool. So Google Seth Bling or tool-assisted speedrun Super Mario. You can watch AGDQ. There's a whole series of these fantastic runs where people are doing this. So Point Adventure Z was sort of our homage to that we released as a CTF challenge to kind of bridge the gap between the CTF community and the speedrunning community. Thanks, Watch. I appreciate that. I heard something. All right, and we actually released it as well on the 30th anniversary of Mario and the NES in 2015. So, oh yeah, I should have pulled this up earlier. This is actually the current, I think, world record speed run. I have no idea how this speed run works, by the way. So we built Point Adventure Z to be exploited. We designed several flaws into it. It actually has code execution bugs where you can use your inventory to write shellcode, and you can move your items around and change your counts by selling and buying things, and you can specifically build shellcode payloads. This speedrun, I have no clue how it works, like absolutely none. They just kind of glitch between screens, and they're off in different pieces of memory. So we should probably actually pull up the replay file and figure out how he jumped straight to the boss there, because that boss does not appear in that configuration on that level. We have no idea. Like, he's literally treating some random piece of data like map data that happens to have a boss on it, and then he defeats it, which triggers the game over screen. So he beats the game in about 1 minute and 30 seconds in this speed run, and the fastest we ever did was about 8 or 9 minutes when we were testing it. So even an intentionally vulnerable one was more vulnerable than we realized. All right. One of my favorite topics of CTFs are visualizations, and yes, I'm being intentionally ironic that the only slide without an image on my talk is the one that says the word visualizations, because that's my sense of humor, so I apologize. Visualizations have been around for a long time as CTFs, usually for scoreboards. So back in DEF CON, this was DEF CON 2004 or 2005, I believe, the scoreboard was actually broadcast on like the hotel's TV. So there'd be like CRT screens, at the time with like this scoreboard, and it was meant to look kind of like a stock ticker. And they were showing the live stats of the game, so you could watch, who was winning. Many of you have seen, I'm sure, CTS with great visualizations and great scoreboards. But I think we've come a long way since then. For example, I think the flashiest is probably NICT out of Japan has a tool they call it Daedalus that's actually been around for about 4 years now. And it's they've been using it in Code Blue and SecCon and a number of other ones. If this doesn't look like anime come to life or Minority Report, then I don't know what does. And they've actually, I think, tried to market it at various times as like an actual tool to companies to visualize attacks. I don't know if your SOC, I mean, other than impressing your C-level folks at a large company, I'm not certain that this would be super useful for actively running at an operations center, but it's really, really cool looking. It is bar none the best looking interface to a CTF I've ever seen. And like I said, I think they actually built it for, or not even for CTS, but then they just decided maybe no one's buying it. We should actually just make it a CTF visualization. But it's awesome. I wish mine looked that good. So one of the ones that I mentioned earlier that I worked on was Cyber Grand Challenge. I'm curious how many people have heard of Cyber Grand Challenge before? More than I expected, so thank you. That's good to hear. The visualizations in the Cyber Grand Challenge were not nearly as flashy as Daedalus, but like Daedalus, they're very, very data-driven, right? And so these were not just like fancy things. In fact, the phrase we were using internally with this was no cyber bullshit. The idea is that we wanted to have, while it should look good and be accessible to a layman, it should actually communicate something. It should tell you something about the game in a way that was actually more useful than just staring at like raw numbers. This view may not do that as much, but there's actually a whole series of videos online, and Vizzy, one of who was the team captain of Kenshoto, which ran DEF CON for many years, was sort of our celebrity announcer for the event. So here he is explaining the visualizations. And these visualizations were a collaboration between myself and Rusty and a video game company. So we had an actual video game company work for about 1.5 years building these visualizations and taking a bunch of binary instrumentation and throwing them all together so that we could show what was happening inside of a game. And so this is like really data dense. You can see which team was exploiting which other team on which services. You can see the total number of services in play. You can see where teams were getting their points from their availability, their security, or their evaluation. If you watched the event live, there was some glitches. it was painful to be behind the scenes because the announcers were sort of like strained at several points with nothing to talk about, and they had to kind of cover. We had a whole like TV production crew. It was a fantastic experience. Like I was on headsets, I had like this push button thing just to talk to the cameraman and the producer and the guy on the stage, and I would tell them, okay, we're sending you information on this service where this team did this. But unfortunately, like we had some trouble with getting all the information up to them in time. So there's actually a recap video that I highly recommend that talks about some more kind of behind the scenes things that happened. This is my favorite visualization of all time, though. This one here is technically very useful, and I would love to see somebody actually take this and do something else with it. The source code has been open sourced. It's based on the QEMU with data flow. And so we generate execution traces. We'll run a binary and we'll trace it. We'll monitor all the registers, the reads, the writes. But more importantly, we log the instruction pointer. And so just by logging the instruction pointer, and then what we do is we map that over into a Hilbert curve. So a 2D plane where, Hilbert curve, what's the exact phrase? It's a space filling mechanism that maintains locality. So the idea just being if you take a number line and you squiggle it up into a piece of paper, in such a way that any 2 points that were close on the number line are now close on the piece of paper. It just means that if two things were close in memory in the linear address space, they'll be close in this 2D plane. And then we extrude this plane over time as the execution progresses. Right? So we run the program, we execute it, and we can see pictures. I'm going to have to restart it here. We can see pictures of a program running. Okay, well, that's neat, but so what, right? What does it actually tell you? Well, one of my favorite things is that when we were developing this tool internally, after the qualification round for CGC, we were testing it on inputs from the teams. And we would take one binary from one team, and we compare it against the reference binary. So we take the original unpatched binary that had a vulnerability in it, and then we would take a patched version from one of the teams, and we want to see how do they differ? What are the ways in which they're the same or they're different? And we could actually tell, oh, well, they have the same shape. They have the same structure. You can see the same loops, the same calls to other functions, and then so the same overall flow and parsing of data would be very visible, but this one's 3 times longer. Well, why is that? It's because in this case, they had lifted to LLVMIR, re-emitted down to native execution, so it was a completely different set of instructions. So if I gave you the 2 binaries, you could do things like, well, maybe we can count the functions, but the function sizes would be very different. The opcodes would be very different. So they'd have certain characteristics that are the same, certain that are very different. But by feeding the same input, generating this trace, we could tell these are doing the same thing. They process the data in the same way very quickly and visually, but you could actually even see, oh, there's their memory safety check. They instrumented all memory reads to make sure that they weren't crashing. And you could see this one function being called a lot. They jumped down to it a whole bunch, right? And so you could just see this visually. You got a lot of information about it. They were very useful when comparing 2 pieces of software. So anyways, Cyber Grand Challenge was a huge event. The data is all lined. The corpus of challenges, of vulnerabilities is all available for research. And so if you're actually doing any kind of binary analysis research, it makes for a really nice test corpus because among other things, they actually if-def'd out all the vulnerabilities in the source code. One of the requirements for the authors was that you had to know exactly where the bug was to patch it. Now, of course, they didn't know all of their own bugs. There were absolutely vulnerabilities that were exploited in the game that were not intended, but those that were intended have if-defs and have documentation, which makes this a very useful test corpus for research. So I highly recommend you check that out. And there's also a recap video that summarizes a lot of the individual events that happened inside it. All right, so now the real reason I'm giving this talk isn't as an excuse to talk about just my favorite crazy things that have happened in Capture the Flag over the years, right? The best part about CTF are all of the fun stories, the unintended flaws, the hacking the organizers hacking you. So I'm going to start with one that I call antenna fun. At DEF CON CTF, teams will often have 2 separate groups because if you're limited in the number of people on the team floor, if you had more than 8 people, you'd have like a separate group of people up in a hotel room. Or maybe even you only had 1 or 2 people at the game floor and the rest of your team hides because you can't concentrate. You can't think in the game floor where it's videos and noise and there's people coming by and bothering you and other teams spying on you. And so we thought, oh, this is great. Our team had a lot of people this year. We're going to get a giant antenna and some like military grade like RF equipment and set up a point-to-point link between the game room and our hotel room. And this was in the Rio that where DEF CON was held at the time, which is a giant tower, of course, in the middle of Vegas, and they have this foil plating on all the windows, which is where the Penn and Teller's face are, and it reflects the sun. It reflects a lot of ambient heat. It reflects a lot of RF too, it turns out. And so we never got our link going, although we did discover later that one of our teams of people was out like positioning the antenna and pointing it at the tower. Hotel security thought that was really weird. For some reason, they didn't appreciate that, and they came out and escorted them away from the parking garage where they were. And one of the other CTF teams at DEF CON took a picture of this out the window and tweeted it, and we're like, oh, there's our guys. I guess they didn't make it. So we were really bummed that we didn't have this like working point-to-point link between our room. But we thought, well, we have this giant antenna. I mean, what else could we do with it? And we're like, well, we could, psyops, psychological operations on our opponents. And so we took it down to the game floor and we set it up. We ran the cables like over where it looked like it was plugged into a computer. And then we would just be working every now and then we'd adjust it and point it at a different team. And we'd work some more, and then we wanted them to think we were Van Eck freaking them and pulling off their images from their monitors or pulling off their keystrokes. And so we got these really nervous looks, and we would intentionally like aim at the different team, and oh yeah, we call people over and point at stuff. We did fess up to them. We didn't want them thinking they were going to get cancer afterwards from whatever we may have been doing. Most conferences have these nice air walls, right, so that they can rearrange the rooms. Some of these air walls come in these little hidden closets. So as I mentioned, the noise and the environment at DEF CON is not very pleasant. And so one year we happened to be situated right by the edge of the wall, and we noticed there's a handle on the wall. We thought, that's weird. Why is there a handle on this wall? And you open it, and there's this like little closet space, which was actually like 15 feet by 10 feet. It's a whole room back there, right next to our CTF table. So half our team went and hid in the closet for the rest of the CTF. It was very quiet. We got a lot of work done. We ran a network cable under the wall, and we had until the staff member from the hotel came in and looked at us and goes, "There's people in here." And we're like, "Yep, hi." He left and let us go. So we were able to keep playing the whole CTF in the closet, but we didn't get kicked out. Tools get broken a lot in CTFs, right? One of the best parts about a CTF is the techniques that people are going to use, and you can screw with them, right? This is what makes it entertaining. You can intentionally break them, and this makes our tools better too. The sort of adversarial model of intentionally attacking our tools and then fixing the tools to handle those things makes them better for the real world, because security is an inherently adversarial environment. It's the one thing that makes security different from many other aspects of computer science and research, is that we are actively combating foes, right? Viruses are being not written by computers, but written by intelligent people, although maybe someday, soon, that maybe the computers will be entirely writing their own. But right now, we're combating smart humans that are attempting to hack us, that are attempting to write viruses, and smart humans are defending us. So this adversarial relationship is fairly unique, I think, to a lot of avenues of research. So you see a lot of tools being broken in CTFs. libpcap and Wireshark always have bugs. If you go and run Wireshark at any DEF CON in the last decade or any other attack defense competition, it's going to crash. And you might even be giving code execution on your box to your opponents, like depending on how good their bug is, how much time they wanted to put into it. Because it turns out Wireshark is nothing but a protocol parser. Lots and lots of protocols, which it will happily decode for you without even asking by default. And protocol parsing turns out to be one of the harder problems and one of the more error-prone, security-prone kind of problems. So there's always lots of bugs in Wireshark. So turn off the dissectors. You'll still have bugs. So run it in a sandbox, run it in VM, or write your own, right? Like actually, I know at least a half dozen teams who've written their own stream reassembly, stream extraction tools specifically because it's too easy to exploit Wireshark. Flooding listeners is less technically interesting, but still entertaining, and requires a little bit of work. Most teams that build their own command and control infrastructure in an attack defense CTF, right, where they're actively getting back their payloads, you might want to encrypt the flag so that it can't be trivially taken off the network when it comes back to you. And so when you do this, it's phoning home or it's connecting back to you. And if you do this poorly, your opponents might be able to just flood your interface with fake keys, making it hard for you to know which ones are real and making you not able to submit them as quickly to the infrastructure. I know several occasions this has happened to real teams. This one happened to me, and it wasn't my fault, I swear. It was a teammate of mine. And it's actually happened in several different events. But when you submit your flags to a score server, don't use curl or a command line tool. And if you do, really don't just pass in the flag as a command line argument, because that's going to end poorly for you. In particular, with an rm-rf, backticks around it, right? And so this actually happened in my virtual machine. I had let a friend of mine use during one of the CTFs, and 9447, an Australian CTF team, was like, "Lols, we put backtick rm-rf in our flags. Did anybody get owned?" And I went and looked, and they had gotten code execution on my box, but I was running Ubuntu, which thankfully, if you've ever tried rm-rf on Ubuntu, at least it used to do this. I hope it still does, so test it on a VM before you take my word for it. But it used to require a separate parameter, right? So you couldn't just type it and it wouldn't nuke your whole hard drive, because it was so commonly used to troll people that Ubuntu actually modified RM so that you couldn't do that, right? So thankfully, that was the only reason I was saved. Like, they absolutely had command injection on my box. And I know Samurai did this as well against APT8 and another one. Chris Eagle has been around CTF forever. He literally wrote the book on IDA Pro. He has been known as Schoolmaster, CS Eagle. He has been playing CTFs longer than there are CTF players who have been alive, right? That's how long he's been playing CTF. 1 year at DEF CON, the last time he won it before he became an organizer of it, they were so far ahead that the last day they just played Guitar Hero the whole day. And the reason that they got ahead is because they had a really, really beautiful payload. What their exploit would do, the infrastructure for CTS have changed over the years. Sometimes they would use xinetd and they would launch a process, and then for a while they would fork the process. They would have a root-owned process to listen on whatever port, and then fork. So that you don't want to let the child overwrite the parent. Well, if you do the order wrong in how you do the forking, the child can still overwrite the memory of the parent. And this allowed Eagle to build a payload so that when he exploited a service on your box, he was able to process inject into the parent process that was the one forking children to answer all the requests. And he was able to patch the bug. So thanks, that was nice. You know, he fixed the bug. No one else could exploit you, and built his own backdoor into it. Right? And so he not only denied all your flags to other teams, but then he had all the flags he wanted kind of coming forward without throwing his exploit. So it made his payload very stealthy. You couldn't replay his attack because it was specific to a private key infrastructure which he had set up in memory in your box. So you couldn't reuse it. You couldn't learn anything about the exploit. It was a beautiful payload, and he destroyed the competition that year. There's been a bunch of what I'm going to call nearly epic hacks against infrastructure. These were things that almost worked but didn't. The telephone infrastructure I mentioned earlier, where you had to submit your flags via DTMF, which, by the way, there was a run on modems at Fry's that year in Vegas because my team bought them all, thinking we would deny them to our teammates to make it harder, because this was like right before the transition where very few people still had modems in their laptops anymore. But the Asterisk server that they were running the VoIP infrastructure on had default credentials on it. And one of the teams was able to figure this out and get into a debug menu, and they were trying to reconfigure the VoIP server so that they would be able to have flags redirected to them first. Instead, they broke it, and so they didn't get any flags, and they just took the server down for a little bit while Ken Shoto fixed it. But it was really close to owning the infrastructure. One team actually had a breakout of the Clemency emulator that they never quite landed, but that would have been insta-ponage on all the services, because you would have been able to own a team's infrastructure and then from there potentially do more, or do some sort of like permanent payload the way Eagle did earlier. One of my favorites is the crypto backdoor. One of the ways that teams verified you were actually running your service in an attack defense type CTF is they would build a backdoor into it so that they had a public-private key infrastructure and they could request the flag at any time. This way, if you had a generic, like, I just removed the flag, or I made the flag not writable, or I modified syscalls, they would be able to verify that by getting code execution in your process with a signed payload from their private key, and they would be able to replay it on your machine to verify they could still read the flags. The problem with their crypto was it didn't have a nonce or a timestamp, and so you could replay attacks. You could actually proxy their attack to somebody else, and because their payload verified they could read the flag, you would get the flag back if you were able to man in the middle it properly. And so the problem is, by the time my team noticed this, DD Tech had changed how they used the crypto backdoor, and they sent the data on a separate interface. There was two virtual interfaces on our machines that year. And we didn't notice that the crypto verifiers were coming in on a different interface. If we had, we could have redirected to the other teams. We already had the working payload and would have been able to get every flag from any other team using the organizer's own infrastructure, but we didn't. So it was nearly epic. Actually epic was the year that roller skaters dropped FreeBSD O-Day and started popping out of jails. This annoyed the organizers to no end. DD Tech was not happy that year, but the rest of the teams thought it was hilarious. Because I mean, who wouldn't like a real O-Day in the middle of a CTF causing chaos and ruckus? It was quite entertaining. That same year, there was some TCP/IP shenanigans. One of the techniques that my team had was the ability to monitor TCP/IP timestamp fields, right? And so Beltevin at AT&T Labs had actually produced a paper some years earlier about using the TCP timestamp field to count the number of hosts behind a NAT. So you could use this if you were sniffing to be able to make estimates about the number. You could sort of get estimates on the number of hosts. Well, in a relatively small network like the size of DEF CON and with good data, you could not just count hosts, you could perfectly de-anonymize, right? You could actually, even though the data was being source routed, and so every connection came from the same IP address, you could actually uniquely identify every speaker with this technique. The cool part about this is this wasn't discovered by one team, but at least two teams independently developed this technique for the same kind of problem, using some original research. You would take the timestamp start, you take the skew of it, which is based on the operating system, and those two facts together would give you a sort of unique fingerprint to let you separate out the hosts. We tried to use it to only allow access to the score server infrastructure so that we would pass all the polls and firewall off everyone else. But we had some glitch where we weren't identifying some fields, and so or some hosts, and so we couldn't deploy it generically that year. But what we did do was block. Oops, that's the wrong one. We did do was block roller skaters from throwing their exploit at us anymore. So after a while, we just disappeared from the network and they couldn't hit us, which actually helped our score a little bit that year. I really, really like troll challenges. So I call troll challenges when the organizers get the hack the contestants back, right? So it's no fun when you're just getting beat up all day and everyone's writing exploits for your services. It's always entertaining when the organizers get to exploit the participants back. Trust Me is an entertaining one that started at DEF CON. It's been fielded, variants of it, and many other CTFs, where you were given a binary, and it was called Trust Me, and you're supposed to run it. It's heavily obfuscated with all sorts of packing and anti-analysis that you're not meant to like undo by hand. You could try to spend the whole time doing it, or you could just trust it, and you could run it. And it would turn on your microphone and record audio, and complain if it couldn't and quit. And it would take a webcam capture, and complain if it couldn't and quit. It would make sure it wasn't running in a VM. It would make sure it was running as root. It would enumerate the number of USB keys. It would do all sorts of invasive, awful things. But if you just let it do it, at the end it would just give you a flag, right? So if you trusted it, you got the flag. And it would send all this data back to a command and control host, I want to point out too, right? So if you like had a spare machine on you didn't care on, or you just were super YOLO, you would just run the binary. I love these challenges because you have this trade-off like in your head. Do you run it? Do you really trust a CTF organizer? These are hilarious. HackerBook was a challenge that we fielded at Ghost in the Shell code that was like a PHP awful interface, kind of like Facebook, where you just had a bunch of different pictures of people. But you were told you had to identify a certain percentage of these hackers. And we got a bunch of random pictures of people from other CTFs, many of whom we didn't know. And our database didn't actually have answers for who all these people were. But we didn't tell the organizers that. We pretended like we had the names of everybody who was in it. And there were several different exploits, actually. There were several ways. You could actually reuse one correct answer several times. There was another PHP bug. So you didn't actually have to know the names of all these people, but some people didn't find the bugs. And so they were just trying to enter the names for all the people, including one person who said, listen, I'm typing the right name for this person. He's a friend of mine. I know for certain it's him. It's not working. And we're like, well, I don't know. Like, what's the image? And he tells us the image. And we have no idea who this person is either. We just pulled it off some like CTF webpage. And we're like, oh, I don't know. That's weird. Keep trying, I guess. And he's like, no, I've got his passport. I'm typing his name exactly from his passport. It's not working. We're like, thanks for that. We didn't really need to de-anonymize him, but I guess we did. So it was a fun challenge there. Experiments was a challenge that Redford actually mentioned to me. That was a Python, or that was easily solved in Python. You were meant to write an emulator that would solve a bunch of algebraic equations. And the easy answer was just a Python eval the code. And you could solve all these math problems fairly quickly. You would go through different stages. One, was 1 + 1, and it would build up to like level 100. But level 99 was a Python injection attack that if you just ran this evaluator, they'd be running Python code on your box instead. HitCon's perfection was a category of challenges that actually abused flaws in tools. Everyone was specifically meant to break a tool, because again, there's always these flaws in tools, and they were able to use it to force you to either fix the tool, write your own tool, or find some other tool to kind of work around it. These are super interesting. At CGC, we actually had someone really test our infrastructure well by tripping over a power cord. And this is kind of like the sequence of events that like just only happens where like multiple things had to fail, right? So first of all, the UPS on the rack had been damaged during shipping. We're told, oh no, that's fine. It's no big deal. Vegas power is very reliable because they make all their money gambling machines. And so the power never goes out in the casinos. I thought, okay, well then we're probably okay without a UPS. And then the stagehand who was plugging in all the infrastructure didn't twist down the 220 volt power connector for this particular rack, so it was unscrewed and could pop out. And then somebody had to trip over the cable. So all of these failures had to come to play, and we had our whole infrastructure for the visualization scoreboard analysis go down right in the middle of the event. And this included the ability to get data from the air gap, because this air gap robot was picking up CDs and dropping them on the outside of the air gap every time there was a round of data. And so I missed a round of data while my servers were rebooting, and we had to go to our backup plan, which involved someone inside the air gap plugging in a USB thumb drive, throwing it over the air gap to somebody else who ran it back into me. But thankfully, we were able to recover with that. So the moral of that story is when you're running a CTF, you need several layers of redundancy, because if you have 4, 3 of them will fail, right? There's always going to be problems. One of the things that I hope I can convince you to do is to contribute. There's a lot of ways the CTF community is benefited, and so I'm asking hopefully for volunteers and people that will help out with some of these ways. I run captf.com, which is a website that archives off challenges because we want to make sure that we don't lose them. These days, CTFs are better about putting them on GitHub or saving them in a place where they can be archived. But these are a fantastic resource for new people to be able to play old challenges. And I would love your help in gathering challenges from CTFs I don't know about, or I'm too lazy to save, or I didn't play. And if you send them to me, there's contact information on the website. That would be helpful. Write tools. And even if you write tools and you don't release them, Binary Ninja was actually a private CTF tool written to Python for my team for many years before we rewrote it in C++ and I have been making it into a commercial product. And many other CTF tools are written in privately, but then when you retire like me, then you can release them and still benefit the whole community. Mentor other people. There's a lot of opportunities to help out others in the community. We've all been helped. There's always somebody ahead and there's always somebody behind. So let's work together. Run a CTF. I have a huge amount of respect for people that organize CTFs. It's a lot of work. You should definitely try it. You will learn as much or more than playing. Finally, if someone could take over Golden Flags and actually run that again, that would be a great thing. This was a award ceremony for sort of highlighting some of the best challenges, best techniques, best solutions in the CTF industry. I did it in 2014, just once. I don't have time to organize this, so I would love if somebody else would take that on. I'll give you the domain name and all whatever art and help kind of promote it. Finally, CTF Time is a fantastic resource, but here's a bunch of ideas of things I'd love to see improved on it. Come and chat with me up over drinks on what else could be done. And I want to give some credits for the photos from WikiHow, the slides, anybody who runs the CTF, these fine folks who all gave feedback, suggested stories, and all the teammates I played with. In particular, I mentioned earlier Rusty, who wrote most of Pwn Adventure, has been just done a ton of work for the CTF community. The slides are already live on that URL, including the solution that I had that broke, by the way, to my challenge. That nobody saw my challenge yet, I guess. Is it? Man, it may really be broken, so I apologize if so. It's working? Oh, they did solve it. Okay, they did. So the flag said, "Stand up and shout, I'm the greatest hacker alive." Oh, is it? Okay, yeah. Let's see what it says now. Is the server even still up? I mean, I gave them root on my box. All right, so now it says, here, let me Let's see if I can do this here. Let's see what the flag says now. There we go. Yes, you're welcome. Dragon Sector is the best CTF team ever. Make sure you come up and get your prize. Thank you for solving. Everyone give them a round of applause for solving the challenge. And any questions? Come up, and if there's no questions, make sure you get a sticker. I have a bunch of stickers up here. Thanks very much.